Hello, welcome back. This is Calculus by Dr. Oz. Today we're given an exercise where we're gonna, in fact, do a lot of stuff. In the first part, right here, we are given parametric equations of an ellipse, a circle, and a hyperbola, and we're gonna try to eliminate the parameter, which is theta in this case, to get down to the standard equations of ellipse, circle, and hyperbola in the rectangular equation form. And once we're done, once we sort of understand what's going over there, we're going to use these results to find a set of parametric equations for the conics. Like in the first case, you have ellipse, circle, and hyperbola. And in each case, you're given a piece of information about the conic. So by using this information, we will try to get down to the parametric equations of these conics. All right, so this will be a long video, so I'm going to split it into pieces. So let's get started. All right, let's start with the first set of ABC here. This could be like a longer video. I may split it eventually, but just get ready for that because we have a lot of questions here. So let's start with the first set ABC. We have cosine and sine in the parametric forms here, and secant and tangent. I'm just telling you right off that I'm going to use the Pythagorean theorem, sine squared plus cosine squared equals 1, as well as 1 plus tan squared equals secant squared. Okay, so I'm going to use these two identities along the way, because this is the way to eliminate theta out of those parametric equations. For the first one, for an ellipse, okay, so I have x minus h to be equal to a cosine theta, and y minus k to be equal to b sine theta. So what I did is subtracting h and k from both sides of the equations, respectively. And now I'm going to divide everything by a on the left and b on the right. Okay, so that I have cosine and sine isolated. So now I can use the first Pythagorean identity, sine squared plus cosine squared equals 1, to get x minus h squared over a squared minus y minus k squared over b squared equals 1. Here we go. This is the rectangular equation form of the ellipse. In fact, this is plus. Okay, don't forget that. That's an ellipse, right? So let's do the same strategy, apply the same strategy for part B. So first, let's do this in one shot. Let's subtract h and k from both sides, and then divide by r, again, by both sides. Divide by r, the both sides of the equation. And you will have x minus h over r equals cosine theta, and y minus k over r equals sine theta. And I'm going to use the same Pythagorean identity to get down to the equation of a circle with center h and k, and the radius r. Okay. In fact, you can even write this in a better form. Let me just show that better form here. You can just multiply everything by r squared at the end, so you get the standard form of the equation of a circle. Okay. Let me erase this part and then finish part C right here. Okay. And for part C, we have secant and tan, so we should use the second Pythagorean identity here. Okay. So apply the same trick, subtract h and k from both sides of the equations respectively. Okay. And y minus k. And divide by a for the first equation, and by b in the second equation, so that you can isolate secant and tangents. Okay. Okay. So here, let me use the other version of this, because it's like this one is equivalent to this Pythagorean identity is equivalent to secant squared minus tan squared equals 1. So this version is slightly better for this purpose, okay? So let me just write what's going on here. Secant squared minus tan squared, which is y minus k over b quantity squared, equals 1, okay? And that's the standard form of the equation of the hyperbola, okay? So we got all in one shot, in fact, that's pretty good. And now we can go back and then think about the second part, set of ABC here, okay, second part of this question. So by using these parametrizations, can you write down the parametric equations for an ellipse, circle, and hyperbola with given properties, okay? So I'm going to stop this video here, and please continue my next video to see what I'm going to do, but keep thinking about part B here, all right? Bye.